Hello, family and friends, people of planet Earth. This is going to be a historical video. I was planning on writing a book, but my time frame has been shortened because I feel like I only have, after today, 3 days left on this planet. So I'm beginning this segment with death. What are we, and what's to become of us? Well, if you were to take an infrared camera, you would see heat radiating off of me. And within that heat is, of course, I am mass, thanks to Einstein. E equals mc squared. Whereas mass would equal energy divided by c squared, the speed of light. So there is energy within every human being. Now, most religions believe in the afterlife. I don't know all religions or cultures, but the ones I have read, most of them do. And within that afterlife is a place where paradise or heaven or whatever you want to call it. Excuse me. But that brings us to what I consider a soul, because I believe in God. So when we die, inside our brain is the soul. And it's this tiny little energy that I call the weak force. Now, what's the weak force? Well, there's three forces in nature: strong and weak nuclear force and electromagnetism. Now, scientists would tell you that there's a fourth, gravity. But like Einstein, he believed that gravity was an effect. It wasn't a natural force. And I believe that too. Gravity is produced. But let's get back to the soul. So the soul leaves the body, but being that we are the weak force, we don't last very long. But because we have a magnetic shield around the Earth, or a magnetic force, and you got the sun, which is streaming photons, which is sunlight, as a particle. Now, the Earth absorbs 70% of those photons, but the other 30% ricochet right off, bounce right off. So that creates an electrical magnetic field around the Earth. Now, us being the weak force, the photon is a carrier of that electromagnetic force. The weak force goes up into the magnetic field, which will happen with me, and then it speeds up, and what it does is it finds an individual photon and they slam together. So if a photon's a circle and you're a line, but you do not enter the photon completely, you're just barely hanging on. And then you get ricocheted right off. And where are you going? Well, you actually steer that photon and you ride the wave all the way to Sagittarius A star, which is the black hole surrounding or in the middle of the Milky Way galaxy. Now, why would you do that? Because you need time, because once you do that, there's only two things you could become at that point. Now, if you believe in God, afterlife, you will slowly enter into that photon. Now, if you believe in nothing, you will absorb that photon into you. So what do we become? Well, once you, with the help of the black hole, you're able to finally get in there and you transform that photon into dark matter. And if you believe in nothing, you transform that photon, but you never really, you shrink the photon down. You never really get it. You never, as far as I understand, the dark energy never takes that photon and disappears completely. But I could be wrong. It could absorb the whole photon. And that's what you call dark energy. So as human beings, we either become dark matter or dark energy. Now, Einstein, in his general relativity, believed that with gravity being in effect, that it creates a space-time. He's not wrong about that, but what produces gravity and the space-time is dark matter. It creates a field because once you transform that photon, and because you approach the black, you actually enter the black hole and you get dispersed out. Right? So it's a cloud of dark matter that surrounds the black hole. And within that cloud, you get the gravity. And then if you're not a part of the dark matter and you become dark energy, you're actually out above, because we create a force field that stops that dark energy from coming back. So galaxies will shrink and expand depending on how many planets are in the galaxy. Now, I've been told there's 18 Earths in the Milky Way galaxy, but I think it might be a little bit more than that, but it makes sense that it's 18 because 70% of suns are red dwarfs, and I don't know if life could be around that. I would imagine if I was God, I'd put life anywhere that has a magnetic field, water, and oxygen. So who knows? But it's hard to create a planet. And because us humans have free will, let me get back to the weak force. Now, scientists have combined the electromagnetism and weak force. They have done it here on the planet. And they determined that the weak force can create the universe, but with their best guess or estimate on how that process works, it only creates 1/1 billionth of the matter that we see today. And because dark energy is 68.6%, and dark matter is 25.6%, and regular matter is 4.9%, you can see how there isn't a whole lot of visible matter that we see. So dark energy keeps the galaxies from colliding with each other. Now, galaxies do form clusters, but that's only if you're not producing a lot of dark energy. And I believe the Milky Way is producing more dark energy than it should. It's slowly shrinking. It's slowly dying. But then you got M31, Andromeda, rushing towards us to save that dynamic. And I'll explain what happens when two black holes collide when I do the next video on life. Because I could actually talk for hours. I had to do these in little segments so that I can get it out to the public all before my birthday, Friday. So I'm going to end it right there. Oh, no, wait. Let's see, I'm doing this on the fly, so please forgive me. Oh, yeah, one other thing. All you astronauts out there, you need to take a second thought about heading to the moon and to the Mars. Now, there was a scientist called Paul Dirac back in the 1920s who predicted, or he was part of a team, because most scientists would team up and then they all share the fame or accolades or whatever. They came up with a monopole. Now, if you were to die on the moon or Mars, your weak force without a magnetic field, I'm sure will create, it's either a monopole, I don't think it's a dipole, but he predicted that there should be billions of them out there, and scientists don't know where they went. But I would think that if you were a weak force and you're sitting on the planet Mars and you're being bombarded by those same photons, you would just keep absorbing, and you grow and you grow and you grow. And then next thing you know, you're destroying the solar system within itself. So I would second guess. I mean, I would have to talk to a theoretical physicist to fully understand what would happen to the weak force if it's bombarded constantly. I imagine you absorb it, you know. But that's what, when you become dark matter, you're patient. You wait. You know, whereas dark energy, you ain't waiting for nothing. You ain't patient. You want to find out what's next. So anyway, that's the boundary. But dark energy will surround the Milky Way, not completely, because the universe is actually flat. But what dark energy is trying to do, or what dark matter, the black hole and dark matter are trying to do, is convert that dark energy back into hydrogen, 75% hydrogen, 25% helium, and a touch of lithium. So we make our own galaxies. We make them bigger by reproducing on Earth and doing that whole system all over again. And yes, you can come back and you could go to other planets. You don't get to pick the planets, just like you don't get to pick your parents. We're all the same. We're all human beings. But on different planets, you'll have different mothers, different fathers, aunts and uncles. You know, as far as I know, I have thousands, which I'll explain in the life segment. And I feel like I'm billions of years old. Now, obviously, I'm not as old as the universe, but I don't believe the universe is 13.77 billion years old either. Why? Because when that dark energy builds up around your galaxy, and since we can't look sideways through our galaxy, we're only looking up and down, dark energy acts like a magnifying, like a microscope. So you're actually peering through the dark energy, and that's where you get the effect, and you could zoom in, and you're seeing the Big Bang, which the Big Bang is true. I'll explain that during life too. Anyway, I must end this now. I hope I could get as much information on the next one, and I'll see you soon. Love you all.